For our capstone senior design project, our group was responsible for determining a phosphorus reduction strategy for the Richford, Vermont wastewater treatment facility. Our group consisted of Rebecca Mangata, Leah Martin, and Jeff Lewis. Lake Champlain is impaired by the nutrient phosphorus. When excess phosphorus is in Lake Champlain, this leads to the process called eutrophication, which causes algal blooms. These algal blooms lead to low dissolved oxygen concentrations, impaired aquatic life, and reduced recreational use. Phosphorus in Lake Champlain comes from non-point and point sources such as agricultural lands, river instability, forest lands, and wastewater treatment facilities. Wastewater treatment facilities account for about 4% of phosphorus sources in Lake Champlain. In June 2016, the EPA established the Phosphorus Total Maximum Daily Loading, or TMDL, for Vermont segments of Lake Champlain to help improve the water quality of the lake. This TMDL outlines new phosphorus limits for many wastewater treatment facilities in Vermont, including Richford. Richford is located in northern Vermont in the Franklin County. Its population size, according to the 2010 census, is 2,308.
Currently, the Richford Wastewater Treatment Facility has two aerated lagoon systems to treat their wastewater. The system is completely gravity-run and has a design flow of 0.38 million gallons per day. The treatment process begins with bar screening to remove large particles. Next, the water flows into the first lagoon. Each lagoon has a capacity of about 5 million gallons. The first lagoon has aeration lines which allow for biological phosphorus removal to occur. Between the first and second lagoon is the addition of the phosphorus-removing chemical aluminum sulfate. Richford has recently been using cerium chloride salt, also known as Sorbex 100 or RE100, in the hopes of increasing phosphorus removal. The wastewater then flows into the second lagoon. This acts as a settling tank for the precipitated phosphorus. The sludge produced from the chemical addition is suction dredged from the lagoon as required. The sludge is placed in an 11,000-gallon storage tank and allowed to settle in an effort to decrease water content of the solids. The supernatant is pumped from the top of the tank and reintroduced to the beginning of the first lagoon. The final stage is the chlorination tank. This kills any pathogens in the water before it is discharged into the Missisquoi River.
Richford is currently regulated by a National Pollutant Discharge Elimination System permit, with a monthly average concentration of 0.8 milligrams per liter and a phosphorus limit of 925 annual pounds. The current system at Richford has an average effluent total phosphorus concentration of 0.53 milligrams per liter or 637 pounds per year. Because of the TMDL, the Richford Wastewater Treatment Facility phosphorus limit has been reduced to 232 annual pounds, or a monthly average concentration of 0.2 milligrams per liter. Four major constraints presented themselves while investigating project solutions. The first is the total phosphorus concentration must be reduced to 0.3 milligrams per liter. Given that the historical flow data does not reach the maximum flow parameters, Richford will be able to discharge a concentration of 0.3 milligrams per liter and still meet their total phosphorus effluent limit of 232 pounds per year. The second constraint is that the wastewater treatment facility currently lacks a comprehensive solids handling plan. While investigating upgrades required to conform to phosphorus discharge requirements, we have identified possible solids handling improvements. The third constraint is that the wastewater treatment facility has limited space available for the addition of a major design upgrade. Lastly, Richford is a small town with little funding for a large upgrade to their wastewater treatment facility.
Our team is recommending a COMAG ballasted flocculation system, which can increase the efficiency of the current coagulation process being used at Richford. Lagoon effluent is directed to the COMAG system, which introduces a ballasting agent after the addition of a coagulant. The addition of a ballasting material allows phosphorus precipitation to occur under a greater mixing regime. Formed flocks are then able to settle faster than traditional flocks due to increased sphericity and a higher specific gravity. This video of a comparative jar test between a conventional flocculation and a ballasted flocculation shows how much faster a ballasted flocculation can settle. Our team anticipates that incorporating a ballasted flocculation system will cost Richford $1.25 million. This cost includes the COMAG system, necessary wet well, dewatering bed, and necessary site improvements. We anticipate the annual costs will run $43,000 per year. We would like to thank the many professionals who have shared their time and experiences with us as we have completed this project.